So I would say let's get this started. So this is the CQRS and Event Sourcing talk, if you're wondering. I'm Marco. I'm the guy that kind of has to maintain some of the doctrine stuff. And I do design framework, so I'm really sorry for both tools, if they displease you. They displease me as well. So first of all, I want to understand what the knowledge level is here. So who has heard of CQRS? Who has used CQRS? 2 people. Who could explain me CQRS? Okay. So this means I'm still in the right track. Okay. Who has heard of event sourcing? Who has used event sourcing? The usual 2. Okay. So why are you in this track? Okay. So fair enough. Today we're going to talk about these 2 patterns, and we are going to move from just having the theory behind them to having an actual working implementation. The repository I gave you has the starting points for that, but we'll see that later. So since you're all nice and well seated, and this is so far away, I please ask you to stand up and come over. We're going to move over here, and I don't care if you're seated well or if you have stuff to do on the computer, I want you here. Because I want discussion to happen. So I want you to actively counter stuff. I realize it's a lot of people, so it's going to be a bit tricky, but let's try to make it work. Never did it with this many people. So first of all, we start with the typical application. So in a typical application, what we have is we have our user. All right. I'm terrible at drawing, so I'm drawing here. I plan to draw on the computer, but that's even worse. So the user sends a request. This is like post/register. And this will be the registration page. Okay, so we're making a RESTful API. Whoever told you that REST is good? This goes through a framework. I make it really, really tiny all the time. The framework really does not matter. Framework is not relevant. Anybody been to Marcelo's talk before? Okay, good. So we got some foundations for talking about some minimal functional programming as well here. So this goes through a framework. Then you have somewhere your service layer. The service layer is like onions. You have layers. And when you peel them, you cry. Okay. All right. And that goes to some sort of ORM. Usually ORM or data access layer. So DBAL, SQL, doesn't matter. For the brave, there's no MongoDB and stuff like that. And then it goes through your database. Okay, so you have something like new user, and you pass it to the ORM, and the ORM will persist it. Now what happens next is that the database will say, oh yeah, I got this. I have the ID. I'm going to send you back the identifier. Send it up, multiple layers until it reaches the user. And then here I'm going to say 301/profile/123. So this is a redirect. It will just tell you where to go. So everyone doing this, right? I think this is very common. There's nothing special about it. If you're in the back, just let me know if you can help you somehow in seeing. I realize the problem is that this is really small. I didn't expect this wide room. So this is very, very common. It works, but it starts becoming really messy over time, and we'll see what we can improve about it. Now, the first thing I want to introduce is the separation between the read side and the write side of your application. And by the way, if you see some logical fallacy in what I'm saying, please speak up. That's why I'm asking you to be here. We need to be able to discuss this. So the problem is these applications become really, really hard to manage because you start having many, many endpoints, and these endpoints are responsible for writing, reading, doing everything together. So the first thing we can simplify on this setup is that we have our user again. We do a post/register. This goes through our tiny framework. I hope it's a tiny framework. Don't use massive frameworks that take over everything. Then the framework will do the usual stuff. So you have your service layer, which is your onion to peel. It's going to make you cry anyway. Then the service layer creates our new user. And then the user goes to the database. So far, nothing changed. What we change here is that we don't really return anything. We just say, OK, I got this to the user. We don't really return the entire view or the redirect or anything to the user. We just say, we got this. We dealt with it. What we can do is we give the user directly up here some sort of ID with which the user can track the request and deal with it later. Now, the user will then do a get to / let's say, my profile. And this get goes through some framework. It doesn't matter. But the interesting bit about this is that we can split it out. It doesn't need to happen in the same data where we are writing. Anybody using Elasticsearch here? OK. Anybody using worker queues? OK. The idea is relatively simple. We have a representation of the data that works while we are here, but then we have some heavy work to do, we have some rendering to do, and so on and so forth. And that's a different representation. And what we do is we have a synchronization process between two data stores. We can say that they're data stores that copies data around. And the reason why we do this is because if everyone reads and writes here, well, first of all, you know about master-slave or leader-follower replication, whatever you want to call it. First of all, you're going to choke the master server because everything is going through there, or at least you have these splits, you have slaves, and then you read data from there, but then you do an insert and the data is not synchronized, and you start having lots and lots of problems there. And the second thing is that, does anybody in the company have one of those printed out database schemas on the wall? Right? Where yeah, well, we did that when you join in a company and you say, OK, somebody show me the database. Show me why this is so complicated. Because usually there is the base of the complexity. The core of the complexity usually is there in a legacy system. And you start having this giant database. And you can't change anything in it, because if you change it here, you break something here. But if you change something here, you may break something there. If you have this synchronization process, you are copying data around. And instead of having one schema, you can design multiple schemas. And the reason for this is that there's two kinds of data structures. This is what we call the write side. And then on the other side, we have the read side. So we have a direct split, which means that these systems can be designed independently. What we are going to do is we're going to put a lot of complexity here, this is not nice, OK? This is still a lot of complexity. We're not getting rid of work. We're putting the complexity here, but we're simplifying the schemas on both sides. So this schema design is working well for one system. This schema is working for another. Anybody has a company large enough to have like a reporting team or something like that? Well, usually what happens is that there are people in another office, like usually in a university, and they need to make reports every month about what happened. So the schema needs to respect this SQL query that was written 10 years ago in Crystal Reports. Okay? And it exports to PDF. And you cannot change it. That's kind of the problem. So everyone is looking here, which is why also companies are going to the microservices approach, because they hear isolation, which is awesome from them. I mean, it's never going to work, but they hear the idea that every team has their own things, and they don't really need to step on each other's foot. We are trying to get there. But the point is we are doing OLTP transactions on this side, which is online transaction processing, which is take some little amount of data, such as form input plus existing user ID plus this, merge it together, do something. On the other side, we're doing massive operations, such as get all the users, find the user with the highest score. I don't know, find the user that has the latest purchases last year compared to the latest purchases this year and do something magic. This is what we call OLAP, which is analytics processing. So that's the difference between the systems. And usually the separation is on this side you have an ORM doing stuff. On this side you have ERP tools, you have SQL, you have giant map reduce operations, you have what they call big data. Yes, basically, that's what you do. But you are keeping them separate. So this is where your data is modified. This is where your data is read. One other thing that is important is, since we were talking about Elasticsearch and workers and so on, this doesn't mean that this is a database. This could be S3, this could be a file, this could be a cache. I worked with some clients in the porn industry, and they have ridiculous hit rates on pages. Yeah, it runs the internet, okay? It still is like that. Facebook surpassed porn in, 2012, okay? But that's it. Still, the rest is porn. There's Facebook and porn. The rest doesn't exist. So what they did is, when something happened here, usually a view, a vote, something happened, somebody subscribed to something, they would directly do an operation that would copy the data over to Varnish. So there is no file. They're actually putting the web page, the rendered web page, directly into Varnish. So this is really powerful. You're simplifying the schema here, you're simplifying the schema here, but you're adding a lot of complexity here, and you're adding a lot of asynchronous processing here. So this is a lot of work. Now, and this is, by the way, this is CQS, kind of just the separation between the two layers. You're separating reads and writes. Now, the last bit that we discussed is that there is an immediate response coming to the user. The user doesn't have to wait. There is processing on the back end, so we can formalize this a bit. So this fact that I'm posting for registering doesn't mean that the backend needs to respond immediately and do all the operations. We can just throw a request at it, and it will do what it needs to do, and then when I'm registered, it will send you an email or something like that. So we can formalize this a bit and get to what nowadays is kind of like the CQRS approach. So we have our interaction again. Our user is sending a post, register. The registration will go through our framework. And by the way, this is just technical approaches. This is not necessarily the way to go. It's just how it works best so far. So if you find a better way, let me know. I'm interested. So what happens now is that our framework, instead of calling a service layer, which is this terrible layer where everyone goes to cry, you just say a new register user. You will create this object, which is a data transfer object. So it's a data packet. It includes some minimal validation rules, such as I need a username, I need an email, I need some other information, and so on and so forth. You pack it into this thing called the register user, which we will call command now, which is important. It is to the imperative. It's conjugated to the imperative, which is very, very important. It will give you expressiveness later on when you start having hundreds of these. So you register the user, and then what happens is that instead of having the service layer, we have something quite squishy. It's a technical layer. We call it the command bus. And the command bus is a function that usually returns void, which means that it's an impure function. It doesn't really give you something back. And the command bus is getting this command, and then it will push it through, I would say, magic here. This is up to you. Could be a message queue, could be immediately executed, could be AWS, Lambda. This is where all this serverless kind of hype goes. So if you implement it, you can say, yes, we're web scale. You'll never get the throughput to justify that. But so you go through that layer. And then on the other side, there is a handler. And the handler is a function that receives the command, and it will do something. So in here, you then have your aggregate state machine and so on. You do the actual business logic. So this connects with the previous talk. This is where the actual business logic happens. The rest is just orchestrating, pushing around data from one layer to another. The aggregate will then be responsible for saying new user on this side and pushing it to the database. Mind it, this is just the right side. What we did with this is we did something that got rid of a couple of problems. We got rid of the service layer. It's gone. It's dead. That's good. Really good. The service layer is kind of existing sometimes down here somewhere, but you don't really care that much. So it simplifies things. You just have operations that you want to perform somewhere. On the other side, it's connected. How it's connected in between, that's up to you. You decide you want to use a message queue. You can decide to use other approaches. Doesn't really matter. On the other side, you write a function. Not really a pure function either, because it will modify some database somewhere, which means it will not return all the time the same thing. And that will then execute everything. The point is that since this is void, you have to return immediately to the user. Since the command bus is a function that doesn't really return you a result, it doesn't tell you when something got executed, you will have to return to the front end immediately. So on one side, you get a very, very snappy front end. It works quite well. It's simpler to deal with. You now have just tiny controller, in your framework, or whatever middleware, whatever you prefer. Creates a command, pushes it somewhere. That's all the HTTP you have got to do. But you return immediately. So the front end is snappy. On the other side, the user doesn't really know when this will be executed. So if you go and read, for example, the AWS docs about Lambda, there is no guarantee that this will be executed immediately. This will be executed when resources are available. So it's really up to you to decide how fast this has to happen, how consistent this has to happen, and so on. Okay? And that is basically the command bus approach. Okay. Can you come? I see that there's like a couple people that are like really just standing behind and not seeing anything. All right. So now, yes.
Should or can the validation of data be done before the command bus?
Yes. Okay, that's a very good question. So let's say that we have a register user. How does the user know that this register user works or not? So there are two types of validation to be considered here. One is business logic validation. I guess the wording is wrong, but from my side. And you do it down here. So in the aggregate logic, in the business logic, before you create a new user object, you, create a lock on the database, invent something. You just say, this is mine. Nobody touch it. Okay? And if it fails, you throw an exception, you make it crash. You don't do anything, up to you how to deal with it. On the other side, on the front end, what you do is you don't really validate everything, but what you do is you have here, you have your, Symfony form, Zen form, Laravel form, whatever you want to have here. And this is form/front end validation. And this can be implemented in a very similar way, but the important bit is that this logic here, the front-end validation, is kind of optional. This one is required. This is a business requirement. So regardless where the command comes from, it should be validated again. This one is just to make it nice for the user. So it's very close to the front end. You just make it nice for the user so you don't just blow up and give them a 500 error. OK. So what we did so far is we separated reads and writes. We introduced a synchronization process between the backend that handles the write data and the backend that handles the read data. Now we introduced a new component, which is the command bus. The asynchronicity of this is not so important. What is important is that you now have commands. Because this is really important from the expressiveness perspective, because these words are understandable to a person that never touched a computer. These words, register a user. I mean, of course they touch the computer in order to understand what a registration process is. But it is business wording. This is really important, because when you look at the high level of what you can do with your system, you need to have a list of these and see what you can do. So this replaces this service layer. We have a service that does 20 things, like we had in the previous workshop. Except that I didn't know if we went to implement a functional version of it. We didn't get to that. OK. So the other concept you need to be aware of is event sourcing. So event sourcing is a completely different way of storing data. And it's something that comes from very ancient times. If you have to think about it, in Mesopotamia or something like that, you had to write parcels about shipments. Okay, like we have 50 sacks of grain going from city A to city B. Here's the parcel that says we have 50 sacks of grain. What happens if one falls off the cart and gets lost? It's written on stone. It's set in stone. You're not going to be able to modify that. You're not going to be able to change it. So you have to create a new one on top and say, we lost this one. That's kind of the idea behind it. So it's the same with legal system, with engineering in construction, with engineering in other fields in general, with anything that has to do with banking, insurance companies. You never change past data. In accounting, if you change past data, if you change the records that you already submitted, you're going to get to jail. It's relatively simple. So that's kind of the idea. So instead of changing data, we create new state. But what we do is, instead of actually saving the new state, what we do is we save the transactions with this state. So in the user example, what we have is again our user. The user does a post to our register endpoint. This goes through our framework. I'm going to reintroduce the service layer for now. Okay? So you have your service layer. The service layer now will not create a user. It will check if everything is all right. It will run the business logic, let's say. And then it will say, new user registered. Attention to wording. This is to the past tense. Okay? It's something that happened at a precise point in time. So it's always past tense. And this is what we call a domain event. This is something that is relevant to us. Of course, I'm making this with an authentication scope because it's the simplest one I can come up with while explaining, because everyone understands it. I think everyone here is a domain expert in authentication. Otherwise, we wouldn't be here. So you have this new event, and now you take that event and you push it to a database. And now this is the right one. Now, how do I get all the registered users from here? Suggestions? Get all events. And then you have to aggregate them, correct? Yeah. So you could have events that register a new user, events that change a user, I don't know, username. So you want the list of all the usernames. You start having problems because you only want the latest one. Anybody done a query where you need to find the latest record in every group with window functions and so on? Yeah? You can finally do it with MySQL since like last year. But previously it was quite tricky, and it is still performance-wise terrible. So that's where the combination of the two patterns works together, because this storage is perfect for storing this information about what happens. We are storing everything that happened in the history of our application, so we can look at it, we can perform transformations, we can perform analysis, we can do predictions, we can do a lot of stuff. But it all takes a lot of time. So what we need is we need a read-friendly data store. And that's why these two patterns, these separation of reads and writes, and event sourcing work really well, because you're never going to go here, or almost never. It takes so much time. So, but what you do is you have an operation, which is usually in functional programming is called a fold left on this. So you're going to iterate over everything that comes in and apply some operations, such as all the users, accumulate all the user registered and all the user canceled subscription, for example, events. You can aggregate and find out who is in your user list. This operation takes a lot of time. And on the other side, you copy it to another data store, which is, let's say, a relational database. Instead, this one is what we call the event store. OK. So now we have the read side, the write side, and event sourcing. Are there any questions so far? Is there anything that smells fishy? Marcelo, you know this stuff. Tell me if I'm doing something wrong. It's all right. It works. OK. So what we're going to do now is we're going to combine everything together. So we are making a kind of a big picture, which is an architecture that works for me. It doesn't need to work for everyone. It's a bit imperative, a bit functional, so it's a bit messy. But it's still so much better than the typical service layer with the massive ORM and the massive schema in between. So what we have is we have our user. Up here, we do our post/register. The post interaction will go through our framework, so the framework stays. It can change over the years anyway. It will change over the years. Your framework of preference is going to be deprecated at some point, yes. And it will be abandoned at some point. So then our framework or front end, doesn't matter. It could be a UI. Okay? It could be the same thing. We're not necessarily talking about the web. This could be a button click on a phone, and the phone does this internally. The framework then produces a new register user with the parameters that you wanted. Obviously, front-end validation if you want. Then it pushes this command that we created. It pushes this to the command bus. So we have the command bus here. Again, void, important, and it returns. Now, the command bus is going to push it to this cloud of magic thingy. Usually, it's a message queue. So this is where you put RabbitMQ, or if you have higher needs, you can use Kafka, but please don't use Kafka unless you really need to. On the other side, there is going to be a handler, which could be this machine, could be a different server, could be on the other side of the world, could be something that is not under your control. Doesn't matter. There is a handler on the other side. The handler is going to run some business logic. So on the other side, you're receiving this command. Now you need to do something with it. The business logic will emit new events, such as new user registered. So as you can see, register user, user register. This is a bit boring, of course. But let's see how we unstuck it. This will go to our event store. Okay, now from here, what we can do is, since the event store is a linear sequence of stuff, whenever an insert on this event store happens, we can observe this addition. So assuming new data comes in, new things have happened, what we do is we have an observer. So if you're into functional reactive patterns, you can do a lot of crazy stuff here, but I'm not able to teach that because I only know the fundamentals of it. So from here, you can say, OK, whenever a user registered comes in, so a user has registered, this happened, you are done, this is saved, nobody touches that, it got saved. Now you are going to observe whenever this event comes in, we're going to have a policy or process manager. We call them both ways. We don't call them event listeners for one reason, because event listener is an inflated term. Every framework uses event listener as a term, so which means that it gets really confusing if you don't call it like that. And by the way, this is probably better also for the business people. A policy is something more understandable to them when you discuss which policy decided that the next thing has to happen. So the policy will then decide what do we do when this happens. And it will see, OK, a user registered happened. I'm going to create a new require user confirmation. And this goes back to the command bus. So this will, for example, send an email, such as like, here's the activation link for your account. So lots of stuff. Other things down here, we have this fold operation, which we call projection. And this operation down here will copy data to this, to a cache, to S3, to what else is there? Elasticsearch. You decide. And you can also decide to start it like this. You can decide to trigger it. So whenever a new user comes in, please update the user stable. You can decide to do that, or you can run them every midnight. Nobody's going to bother you because the number of registered users on your forum is not updating live. Nobody cares. So this is the big loop. Well, it depends if it makes money. If you make money out of it, of course. But nobody's going to make money out of the number of registered users by the minute. So this is kind of the big picture. It is one approach to it, and it works really well so far. The immediate gain from this is that, for example, the typical approach to a user registration is, OK, I'm going to save a new record with the user, and then I'm going to send an email. What happens if the email sending fails? Or the opposite. I'm going to send an email, and I'm going to save the user. What happens if saving the user failed, but you already sent an email? You can't really undo it. So what we did here is we split this into two steps. One step is registering the user. The second step is telling the user to please continue the registration. And these are actually steps that you discuss also during the meeting. Okay? For example, the Starbucks example. You first do this, and then do that, and then do that, step by step. And each step has a consequence, and you can do another action, and that unstacks the entire loop. So this is a very well-working architecture that I've been teaching for a lot of time. And so far, I mean, please challenge it. If you see problems, please let me know. So that is one immediate gain. The other thing that we didn't discuss is that this event stream, since it's a list of things and you can only append to it, this means that anything that is in the past, you can trust that it never got changed, which means that any copying operation you do, you can trust it, which means you can cache it forever. So this is really powerful, which means that you can like keep an index of Where did I get last time I did a report? Okay, I got till 2 days ago. So next time we need to do a report, we're just going to take the old report and add the data from the last 2 days. We don't need to redo everything. So this is a bit of the advantage there. So this is the big architecture. Are there any questions so far? Yes?
What happens if the failure is business logic? So you research
Yes.
the user, but I mean, it's a first validation of the input, but then business logic says.
Right. So you can. So if you have a business logic failure, this happens behind the handler. So there's no way for the user to know what happened. So if it is a technical failure, such as, I don't know, the database failed, this is what we call a retriable exception. So really common in the MongoDB world, like try to write 5 times, you know, and just get the first one that succeeds. It's kind of like brutal, but it works. Yeah, it's barbaric, honestly. Don't necessarily do it. So what you do here is you actually have a transactional boundary around this. You're going to put it here. This stuff happens in a transaction. Use transactions, they work well. It's okay to use transactions. You don't have the scalability problems that require you to skip transactions. Okay? So if a technical failure happens, you can roll back, retry, and then you retry 3, 4, or 5 times. When it fails 5 times, you're going to send somebody a message, like a developer, like, this is failing a lot. What is going on? Please put it in the logs. That is one thing. So this is usually a developer mistake. But let's say that you forgot to add some validation here, and down here it fails to validate, such as you forgot to check up here whether the user already exists in your database. Down here it's going to crash because it says, oh yeah, duplicate user, I can't do that. So what you have to do here in that scenario is you can either just ignore it, drop it. It depends if you make money out of it. That's the point. Does giving the user a feedback produce you money? Okay, so don't overthink it. If it just fails and it's okay for it to fail and you forgot, in theory you should improve the front-end validation. But here, if the business logic fails, this is not a retriable exception. This is something you will need to have as failing, and this is okay. So you can either make it crash, or you can produce, as we were discussing in the previous workshop, you can produce a different type of event. So you can say, this failed because this, and that. Please tell the user. One good example is that you do a checkout. You started the entire checkout process, but at the end of the checkout, somebody already got your product. So you do a checkout at the end, and the product is no longer there. Somebody else got it before you. So you're going to send an email to the user, we're sorry, we didn't charge your card because we couldn't finish the transaction. So it's up to you to decide how to deal with this. But yes, this complicates things. This fact that we don't have immediate feedback means that for the front-end developers, this is much more complicated, because there's no real immediate feedback of the response. They have to find a different way of making it work, which usually involves querying down here and asking, is it there yet? Is it there yet? And keep asking. Anybody seen Google's Firebase? Tried it? Anybody tried it? No, it's too expensive, right? But this is one very, very cool thing. If you're building one of those single-page applications, single-pane applications, I call them, if you're building one of those, you can have a nice UI, you know, like a bank with all the nice spinny things, or like a Bitcoin current market price and so on. And you can store the information about the latest price in this Firebase, and the front end is connected to it, and it will receive the updates live, which is really nice. So you have this WebSocket. If you ever did AngularJS or React.js and you have this kind of two-way binding, this is like a one-way binding. It's only pushing to you. So you insert into their database, and they are going to push to your front-end users, which is going to save you a lot of time if you can do it. If you're in the medical business, you can't because it's managed by Google. And you're not going to give data to Google. So there was another question. Yes. Well, okay, that's actually also very important. So this process of copying data around happens in a separate transaction. maybe it's not even transactional. You're just copying data from one system to the other. So what you will have is that this completed, something else starts, and maybe it depends on data down here. Depending on how much this is lagging, you may have bugs, or you may have problems with the front end. Because this data is not necessarily consistent. It will lag back a few seconds, or maybe a day, or a week. Depends on when you run it, or how much time it takes to copy over the data. This is effectively a cache. So when you design for something that needs high consistency, you don't ask here, you ask here a question. When you ask here a question, you have a high performance problem, high performance overhead, so you have to always be very careful about that. But otherwise, you ask down here, which is very fast, quick, could be an in-memory cache, but it may be outdated. So you need to at least keep in mind, if it is really, really important to have that particular number updated to the last second, I'm going to store the number and when it was last updated. So I can take a decision on whether to take it or distrust it. So this is a business decision to do. How important it is. The business doesn't care about this. The business, they don't even know there is this stuff. All they will tell you is that this number is really important. Okay, so other questions? Yes?
What do you compare with notifications?
Concurrent?
Concurrent notifications or events that needs to be dealt with in a specific order, but because you put in a queue, you don't know which order to post.
Right. So, well, execution order should not really matter that much, but if it matters, if you have concurrent notification on the same subject, let's say, the same user managed to send in 40 messages in the same millisecond, and they're coming all out on the same time on 40 different workers that are all going through the same database, you're going to have a problem, of course. This is an insert-only structure. So what can happen is that some of this data is inconsistent. For example, you have a double booking on something for a room. So two people are looking at the same hotel room in the booking system. They book, they pay, they do everything at the same exact moment. And for some reason, there is also some lag here, so you will have a problem. So in that scenario, what will happen is that you will have two bookings for the same room in the same period of time. So if you have a scenario like this, what you have to do is you have to design a report that will go through this, find double bookings like every hour, I don't know. It needs to query data only on the last hour. It doesn't really need to query all the data. It just gets that and then figures out, oh, there's a double booking, so I'm going to actually contact support and ask them what to do. Why? Because this happens so rarely that it costs you less to have the eventual consistency there than to actually fix the problem from a technical perspective. If you try to fix it, you're going to spend like 6 months designing some kind of locking infrastructure that makes sure that everyone is only using one thing at a time. These things exist. It's just complicated to use them, and they're going to slow down the entire system. That for then, that one scenario where this happens, just let a human decide what to do. Do we want to send an email to this customer telling them that the booking has to be canceled? Do we have to, which one is going to be canceled? Maybe the support can decide, oh yeah, this is a gold member, whatever. So I'm going to give it to this person rather than this rather unknown person. Obviously that's biased, but still. It's something that is an edge case. So it will not produce money to fix the edge case there. That's kind of the point. Other questions? Yes. Yes. So I would produce the ID up here with a trusted ID generator that you can trust. Generally, a UUID works enough. Just don't get it from the front end, not from the user. Get it from your own system, a system that you control. There are many different ways. You can go with crazy stuff. If you want incremental IDs, you can use vector clocks. It's up to you how complicated you want to do it. Not really important. A UUID usually cuts it and is sufficient. Okay? When this happens,
Does this solve the colleague's problem?
what do you mean? When what happens?
So
When you have a collision?
yeah.
When you have a collision, you don't really have a collision down here. You have two entries here. So what happens is that the projection will keep working as usual. It doesn't really care, because the projection is just copying over data. It doesn't matter if the data is inconsistent. If you have a double booking in there, it's up to you to find out that. Okay.
You can do an aggregate with a cross index for those things. So that
You can do that. Yes, you can do that. But usually the simplest solution, and we'll see it in the framework that we're using, is that you have a unique index in here, which is a bit horrible, but it works. Okay. Well, the projections stay as they are, but let's say that the problem is only when you change the definition of these. You never change the definition of an event. You only create new versions. When you have new versions, such as a new user registered with password, which is different from new user registered, okay? Just because we change the definition somehow. This is very generic. Don't use this naming. Use naming that is very specific to your domain. And probably don't use the authentication domain as a system. It's probably not the best system to be event sourced. But you basically have to, yes, you have to design new projections. When you invent new events, you have to consider all the projections that may be affected. The good thing is that the projections are really simple. Projections are usually flat tables, so taking a decision on whether they need to be adjusted is usually quite simple. Okay? The same user. You can have actually two reservations. If you didn't have any locking.
What happens if you want to load only one reservation?
If you want to allow only one, what you can do is you can have somewhere else. I'm going to put it down here. You're going to call it a lock. And you're going to use the lock. You can use that if you want one interaction to only happen at a time. Generally, it's not worth doing. It's really, really hard to use timing attacks like these. And this kind of paper trail, if you have somebody that starts doing these reservations with their credit card and they start gaining from it, this is everything is logged. So what happens is that this person is going to get caught. Okay? So it doesn't really matter. You have it there from a legal perspective. This is important. That's another very important thing about this system. If you have legal requirements, which was one of the main things of this system, people from the legal department can now use this data. If you give the people from the legal department in a process, in an investigation, you give them an audit log of a database where everything is just columns that changed, they don't care. This is not really legally viable. It's not used by the legal system. Yes, they can find a fraud, but they can't really verify that it was done, that change in the database happened because of this. They only know that a change in the database happened. They don't know how. Okay, so they only have this change. Now you can have that because you gave the change a name and you said who it was and why it was and so on and so forth. You can store it here. So this, from a legal perspective, is really, really powerful. Okay, so I think that's, first of all, for now, enough theory. We're going to move on and start looking at some code. And I'm sorry, for those that didn't see it, I can actually invite you to come over and see the slides even later if you want, or after the workshop, it's all right. You're going to stick around. What I have set up for this workshop is a tiny Zend expressive application. It's relatively simple. So if you go in there, you see the interesting bits that interest you are the SRC directory, where you will place new classes when we will have to write any. We have our container PHP, where I did all the wiring. It's all very, very basic PHP style code. It looks like a Pimple container for those that are not familiar with the dependency injection container style, and the public directory. So you will have to only edit container, public, and SRC. There is not much going on there. So how does it look like? First of all, let's go and look at what this application is about. So the idea is that you have a building, And you have one of those machines where you just go through and it records whether you checked in or checked out. Okay? So that's kind of the idea behind it. You have everything installed on your VM. The repository should be called PHP CQRS. So let me see if I have the VM running. No, I don't have it running. So all you need to do is, first of all, run it. In order to run it, I usually use the PHP internal web server. So it's php-s localhost 8080, and I use -t public. And this will start. Is it running for you? Okay, good. That's sufficient. If you have a web directory to run it from, that's right. I just hope it's on the root of the domain. Okay, good. That's sufficient. So when you run it, all you will see is a page like this. It doesn't say much. So this is, how is it called? Hotel loan. And you see that my UX skills are not that good, but at least this page is responsive. So, all right. So when you submit it, all you should see really is the same page again. But on the other side, you should see the request going. So I want you to go through this and just make sure that everyone is on the same page with this very, very little step. Right. So I can really endorse use this internal server. It's much simpler than in Apache setup with virtual hosts and whatnot. Much, much simpler. So for those that have it running, you should see something in the data directory. There should be an SQLite database now. What I can suggest is that those that are already there, try to open it with the IDE. You can open it as a data source in the IDE. Yes, okay. So go to github.com/shittysoft. Yes, I'm not kidding. It's called shittysoft. Shitty with 2 T's. Soft. Yes, that's where everyone gets my workshops from. That's the one. Yes. You should be able to run a composer install and the PHP internal server, and you're fine. Okay. Download this. When it's asking you to open as a data source, let me actually do that real quick so I can show it. So if you go to the data directory and you run this, you can open this and say, I'm going to open it as a data source. Okay, so you can really open it as data source. And it's going to open this dialog. Down here, if you never did this before, it's going to tell you to download some drivers. So good luck to the Wi-Fi. It should be okay, though. It's only like 5 megs. And once you have it, you should have it here on the right. Works. Okay, yes. Yes, no, that's why I suggested use the internal server. I don't think the Apache setup is designed to handle these redirects. So this is the command. Okay? And then run it from localhost 8080. You open the page. Yes? Yeah, just download that. Okay. All right. So if you run the page correctly and you manage to do a request and so on and so forth, I set it up in such a way that it will automatically create this SQLite database. We are still using a relatively old version of the frameworks that are involved, but they run stable. They're quite okay, and it's perfectly okay for demo purposes. So you will see that there's this the DB SQLite. And in this DB SQLite, we have, which is really important, this event stream. So here you can see how an event stream, a very simplistic event stream, is built. And most of the time, you will not need more than this. And an event stream is basically a table. Sadly, SQLite doesn't really perform operations such as prevent and delete or prevent and update and so on, so you can do anything. But you see it has an event ID, which is usually a UUID, usually. In this case, you see chart 36. That's not the best way to map a UUID, but it works. Then we have a version. And that's where the trick with the concurrency happens. Version is incremental. We have the event name, which is a class name. This is the name of the class in your code of the event. So the event is an object. You create it in your code. And here you have the class name saved. You can also use other systems to map it. But generally, this is the class name. You have a payload. And this is going to be JSON data. So it's all the data packed into this event. We have a created at. Careful that created at is the time this event was created in the application. It's not the time the event was inserted. Those are different times. Then we have an aggregate identifier and an aggregate type. To this we'll get in a second. But the idea is that we're interacting with a building. So this is really a simplistic interaction that is supposed to just create the first aggregate in order to get started and do some coding. After this, we have a couple things which are interesting, which are the causation ID and the causation name. These are the commands that caused the interaction. So I'm going to go ahead and select from my event stream. And so as you can see, I have an event. The ID is not really that important. It's version 1 because it's actually the first event in the entire stream. We have an event name. So this is a new building was registered. We are registering that we introduced this machine in a building. Obviously, I made up the domain, so it's obviously to be interpreted. I wanted to use bowling as a domain initially, and it was already too complicated so for a workshop. So you have the event name, then you have a payload. In here you see I stored name, event, this is the hotel loan. That's what I inserted in the field. We have a creation time. We have an aggregate ID, which is another UUID. And an aggregate type, which is another class name, which is a building. I just stored a building. Marcelo is currently pulling his last hair because of the naming that I have. This is pretty much what it looks like. Now, the next interaction I want to do is you need to get this aggregate ID. Since I'm so good at UI, this application almost has no UI. And I have a very, very advanced templating engine called PHP that I use for the HTML views. But I want you to go to a page which is the same as you currently have. So it's localhost 8080/building/ the identifier of the aggregate. And you should see something like this. So go into your event stream. You need to have the event stream open and go and get the aggregate ID. Put it in the URI. So it's localhost 8080/building/ then the identifier directly. And this is what I will give you as next thing. So this is where you start doing some code. We'll first look at the existing code. Yes. Database is empty. Did you submit the form?
Yes, twice already.
It's not loading at all. Okay, so let me remove it here. All right. I'm gonna open it again as data source. The thing here is we have a building. I can walk in. I can walk out. Can walk in, can walk out, can walk in twice. Doesn't matter right now. Okay? That's what we want to first achieve. We want to at least log this interaction. So we're going to do something relatively technical about it. So, things that you should see first before you kind of get started. We have an index page. I use this weird immediately invoked function style. So I never have PHP files with global variables. I despise global variables. I do some error reporting, so at least you don't have to go crazy when something crashes. Then we get this container thing. This is the dependency injection container where most of the stuff happens. Some more error handling, doesn't matter. And then down here you have the actual application. So for the Zen framework folks that were yesterday in the workshop, it's relatively simple to understand what this is about. For the others like Symfonians and so on, it's pretty much like looking like a Silex app or so on. Relatively simple. So you have a get interaction. Then I use my advanced templating engine here to produce some output. Works really, really well. Then we have this register new building. This is where you should put some focus right now and look at it. So as you can see, I'm getting this command bus thing, and then I'm passing something to it. I'm dispatching something against it. And then I'm just redirecting. I don't care about the response. I just dispatch, and I don't care if it does work or not. It's not my responsibility here as a controller. We have the building ID. This is the page that you're looking at now when you look at this. This is this page. So this building ID, you see it requires the building ID as a parameter. It will render just some template. And down here is what you actually need to work with. So you have two empty blocks here. This is the building ID check-in interaction. So you post to it, and you should perform a check-in. So what we will probably have here is firing another command. So you need to look at where the other command was fired and have an idea of how that worked. Then we have a definition, which is this container PHP. Here I wired everything together. So basically all I did is I took this stuff and I implemented it for you in this container PHP. So you have a connection, which is going to give you an SQL connection to your database. It's this block. Also, when it connects, it creates the database. It's not really important, but you need a database. That's where our events are going to be saved. Then we have the event store, which is the actual abstraction, PHP level of this block, which is the persistence of your events. This event store uses an event bus, and basically when you persist to it, it will publish these events after they are persisted. So first of all, save them, then publish. So it will utilize down here an entire event listener. We will go to that later. So this is basically this part, this observer thing, which will react to things that happen. Then down here we have the setup of the command bus. And the command bus uses a service locator plugin, which means that for every command that comes in, it will look for a service called exactly like the command. Let me simplify this for you a bit. So let's ignore the command bus for a second. Let's go to the very, very bottom here, and you see there's like register new building. This is what a command handler looks like. So this is a factory, a service definition that will give us the command handler. So the actual executed piece of code at runtime, it's this one. This is how it works. So effectively, all we're doing in this command handler, we're taking a repository. This is the building repository. And we are adding a new building. That's what the register interaction is doing. So that's how commands are wired together. So the command bus only has this responsibility of getting the class name of the command that it is receiving and passing it over to a command handler. Then we have some message queue stuff. We will not get to this today. It's too much stuff there. This is asynchronous processing. Very useful when you start to grow on this system to find out what needs to be logged and what not, and to understand where it may fail or not. But this is the actual interaction. And if you look at the API, these buildings, this is your repository. If you look at the API, and I'm going to go to the interface, this is part of I wouldn't say determine, but almost. This is giving you a building by a UUID. I didn't bother with designing a value object for an ID. Too little time, too many concepts for that. But Marcelo covered it this morning, which is good. Or you can add the building. That's how the storage works. And we wrote an implementation for it. So this could be implemented in Doctrine, Laravel, whatever you prefer. You see, there's nothing different from a typical data store. But when you look into the current implementation, we are using this building repository that uses an aggregate repository, which comes from this library called Prooph, which is kind of like the core of the infrastructure layer. So all it takes is it takes these objects and then figures out, oh yes, there are events and I'm going to save them. Let's go back a bit. So we wired the command bus, the event store. Now what the heck is this building and how do I build it? How is it created? How is it saved? And so on and so forth. So this building repository is responsible for loading and saving it. The actual building class is this weird thing that extends something from a framework, another big violation of rules, but it works and gets stuff done relatively quickly. The building, it looks like a plain old PHP class. It looks like an entity from a typical ORM style application. What is interesting is that internally, this object does not really store anything besides the list of things that happened. So if you go to the constructor, which is this public static function new, so we are registering it. Why does it complain? PHP 7, yes. Okay, so this public static function new, you see we are creating a new instance of this, and then we're saying record that a new building was registered. So this happened. That's what the difference is. So internally, this object doesn't really store any fields. It only has this, it is a big stack of events. And when we create it and then we pass it to a repository, the repository has some, I would say, magic for now, that will just extract these events from it. So what I left over is you have to implement a check-in and a checkout on this. So it's empty right now. And this check-in and checkout can be built from the existing code. So the last bit that we miss is this particular event and the command. I'm going to go to the SRC directory. That's where all these classes are defined. So we have a command, which is registering a building. You can take it as a blueprint for an interaction that says check-in user or check-out user, something like that. And on the domain event, we have a very similar data structure which extends this aggregate changed. So these are the actual things that are moving around in your system. We're pushing in a command on one side. This is a command. They register a new building. We're pushing it in. It comes from the index PHP. It goes to this command bus. On the other side, there is going to be a handler, which is in the container PHP down here. This is the piece of logic that creates the handler. Then this piece of logic will call building new, will create a building. So it will go into the building down here. This will effectively instantiate itself, and then it will record an event. And then we are going to give this instance to the repository. So you see this buildings add. And we're going to say, please save it. That's all we say. And after this is complete, the repository will take the new events and pass them to the event store and add them to the database. So my suggestion is, and I'm going to give you time as much as you want right now till the break. Oh gosh, okay. We're going to probably write it together after the break then. But still, give it a start. Try from the building, from the check-in interaction in the index PHP, which is line 70 there. Start writing there. What happens when you fire a command? Can you write a new command class for checking in a user? You can really take the existing command class as a blueprint for a new class. Fire it there, and from there try to continue until you get to make it work. This is going to be a lot of try and fail, but it's going to force you to read through the existing code. The command dispatching is, look at the container PHP, down here, 195 to 201, that's the current command handler for the registering a building. You need to replicate one that does the same, but for a check-in. Of course, on a check-in, you don't create a new building, you want to use the existing one. All right, so I would suggest we start writing some code. I'm going to actually just write it. You don't need to continue, because I will give you a branch. I just want to want you to follow along. So the first thing is I suggested to go outside in with this approach, because you need to see every layer and have an immediate crash and fail to have a feeling of how this works. When you will implement this for yourself, you start from the business logic and go outside. Okay? So we are doing it the reverse on purpose, so you stumble upon every problem. That's necessary in order to understand every bit that is going on. The first thing I want to do here is I want to have an index page that does something. I'm going to actually take a bit from this register new building and a bit from this building ID. So I'm going first of all to copy paste. Copy paste is a great way to write code, say nobody ever. So I'm going to call this interaction check in user, and I'm going to say from building and username. And what I need to do here is I need to actually go and check the form, because this form, I don't remember the field names for it. Username and the building ID is in the URL. So I'm going to copy the building ID from the URL up here. That's my building ID. I'm going to check in user from the building, which is building ID, and the parsed body parameter, which is username. And that's what is getting dispatched. And I'm going to redirect to building / building ID to string. So this is going to bring me back to the form. First of all, going to run this and see how it crashes so far in order to reproduce the same failures you experienced. So I'm going to say marker is checking in, is going to crash. Well, first of all, the command is missing. Let's write that. So I already wrote some commands. As you can see, I put them under domain. For me personally, this stuff belongs to the domain, because this is wording that the business understands. Of course, we are making a very made-up domain here, but when you talk about banking and so on, these interactions are relevant to the people, you know, in the sharp suits and the blue tie or whatever. Don't get me wrong, I also have to wear that sometimes, it's painful. Okay, so check in user is the interaction. The constructor is different. I named it from building and username. So from building and username, on this side we have a UUID, which is the building ID, and then a username. Up here I'm going to just replicate it because I'm lazy. Initialize all these fields, yada yada, there we got it. So, obviously, building ID and username. I'm going to make accessors, so building ID is going to give me a UUID. No recursive functions there, okay. You see I get rid of the get. One reason why I get rid of the get personally is so that frameworks stop doing magic with my classes. Because as soon as a framework sees a get, they start doing stuff. So I purposely induce pain here. That's done on purpose. username is just returning the username. I don't know if you went further down here, but then you have to implement some details. Yes, thank you. So what happens down here is that these commands, as we discussed before, they will somewhere be pushed to a message queue or something else. So you need to convert them to JSON or XML or something else. So Prooph implements this abstract method. You have this payload method where you can actually store the information in a serializable friendly way. So building ID, and it's going to be the building ID, but to string, please. Because otherwise, JSON encode and decode will just give you a hash, and that's not really useful. Down here, I do pretty much the same. I say this username is equal payload username, and here I apply the transformation for the building ID. Building ID is equal UUID from string payload building ID. You can actually see that the UUID class for the question about name constructor has multiple name constructors from string, UUID from bytes, from integer, because every different, if this was one constructor, you would basically allow anything through there, and then it would be a mess to understand which format was used. So this is the command. It should be recognized. Let's try running it. It's going to fail in a different way now. So when I run it now again, it will say, okay, command building blah, blah, blah was not handled. So was not handled means there was no handler on the other side. There was nobody listening for this. This is really important. There needs to be one and only one command handler on the other side. So this is configured in the container PHP. I'm going to write it down here. So this is the interaction. The interaction this time is for check in user. So I'm going to actually fix the command down here as well. The interaction is quite simple here. So I'm going to say buildings get with the command building ID, and then I say check in user with the command username. Let me put it in a way that everyone can see it without squeezing their eyes. So that's how it looks like. So the interaction is really simple. It's just a connection layer between the infrastructure and your actual business logic, because the business logic is this particular check-in user method. So now if I submit, what is interesting is that it should work, but it will just, do nothing. So if I go to my database, nothing new changed, which is kind of interesting. This thing, if there are no events, then nothing changed, according to this framework. No events means nothing changed. Okay, so this check-in user needs to be tweaked now. And by the way, I should probably throw an exception here for the next person having to do anything with this. So in order to have this work, I'm going to use the same boilerplate I had above, except that this time we are in an instance method, so we can use the current object as the target. So the username is the username provided. And another thing that changes is that this is no longer a new UUID that I'm creating, but I'm going to get this UUID to string. Lastly, I need to obviously change the event name. So this is user check it in. Okay.
Sorry, why are you using the current UUID?
Because it's this. Oh, that's interesting. Because that parameter, if you look at it, this parameter is. Oh, yeah. I don't have auto-completion there. I have it here. This is the aggregate ID. It's not the event ID.
Okay.
So this is. If you have the user ID, this would be the user ID. If you have the shopping cart ID, this would be the shopping cart ID.
So that's the ID of the aggregate that dispatches the...
Correct. So in this particular framework, every event is somehow correlated with an aggregate. And this ID gives us which aggregate. So this is a convention that works for mostly all problems. if you want to do event sourcing with some rules, workarounds, you can also do it without aggregate IDs. You can do also that. So I need to also implement the user checked in. So I'm going to copy this domain event. I'm going to say user checked in. And well, honestly, this doesn't really need anything for now. One thing, you see this is a magic structure. This is an array with dynamic keys. This is really squishy. So when you reach production, don't use like this occur method because it will bite back. Instead, like write a named constructor or a constructor with proper type hints and so on. So you never forget a field. It's really, really hard to fix a problem once it landed in the event store. So it really is problematic to fix past events. So now we can import it. Let's try it again. Now it will fail in a different way again. So Marco tries to check in. Okay, so missing event handler method when user checked in for aggregate root building domain aggregate building. So it is missing one of those when methods. Where does this convention come from? This convention comes from the parent class of the building. So this aggregate root base class gives us some basic inner works of how an aggregate behaves. I extend from it because it's really simple, but it's so easy to get this wrong. So I usually extend from it because the people that made this framework are exceptional at bug. I would say this is the only framework that I use for 2 weeks without finding a bug. Okay, I found it right after, but still. So this aggregate root class, what it will do is that every time we call the record that method, it will also look for a handler method called when event name. The reason is that whenever we produce a new event, we want to move the state for the aggregate. So for example, we have purchased, then the status of the aggregate changes. So we have to move forward in the state machine. This is exactly what was in the workshop this morning. So every mutation, every event being produced moves the state of the aggregate. In this case, we're not doing really anything, so I'm going to write an empty method. Public function. Honestly, this shouldn't be public. Protected is also okay. Protected function when user check it in. Event, and this is void, and I'm going to say ignore for now. So because we're not really moving any state, we're just logging the interaction. It just lands in the event store. So what happens now is that if I refresh again, I should see the page. If I go to my event store, if I did it correctly, hardly loved it, live coding. There we go, second event. So this is the check-in interaction. So now we see there is something new here. There is a version 2. Why? Because this is the second event that applies to this particular aggregate. Okay? So your events are always ordered and always correlated with an aggregate when working with this specific tool. It doesn't mean that this is the rule, but still it works really well for most domain. So what I'm doing now is I'm committing this. And this is the check-in functionality. All right, and I'm going to push it up. So you check out this branch. What I want you to do is to do the checkout, the very symmetric functionality. So all you will do really is just go through the classes we just wrote and reproduce the same functionality for the checkout. So if you pull the current remote, you will see there is a feature / check-in. Use that as a start and implement the checkout. Okay? Yes?
What can you do is that username that's checking linked to the
the user that is checking in, because it's in the URL. When I check in, this gets submitted as well.
Yeah, but in the event store,
In the event store, what?
how do you know that the username is
This is the aggregate ID. This is the aggregate ID. So all the operations on a single thing are aggregated by this column in this particular storage. I've seen other event stores where the aggregate ID is just in the payload. Also okay. No, the aggregate ID is a separate column, and the payload just has the username here. So the same thing with the checkout. It is boring, but it will at least force you to see every piece of code that was changed. So reset your changes, start from that branch, give it a go. So if you lose any of the steps, by the way, I'm going to make a repository with pull requests for every step we did. So you can have also an overview of what we did over the day. So an aggregate, what is an aggregate? An aggregate is something that has nothing to do really with event sourcing. It's more of a DDD term. It is a state machine that aggregates around a piece of logic that you can consider a part of your domain. So a checkout. A checkout you can start it, you can provide payment information, you can complete the payment, you can provide shipping information, you can confirm the shipment, and so on and so forth. This is an example of an aggregate. So it's pretty much like a state machine. What we did inside here is that the implementation detail is event sourced. So that's all that happens. If you look at the base class of the aggregate, there is a method called reconstruct from events or from events or something like that. That is where the actual construction happens when the repository loads this aggregate. Yes, reconstitute from history. So every time you load one of these things, you're replaying all the history of everything that happened.
What if you want like a read model for the username?
That's something we will do. The read model, we need to do it. Actually, I will do it because we have very little time. So how many here are properly confused by what they saw so far? Okay. How many would say that they will be able to do it at home? Okay. 50-50. Good. I'm here all day tomorrow as well, so if you really need to understand one particular concept more clearly, please do ask. We do it with pen and paper and a beer. So I'm going to implement it real quick. So, and again, this is just to build some muscle memory, to get used to this. It is not as scary as it looks like. Compared to the typical approach, you have to write a repository, save transactions, and you have to figure out service layers and how to name the services, and so on and so forth. This is just a very different approach, but it's not much more different. So, we're going to make a checkout user. We need a checkout user. It looks exactly the same. There is nothing to change. The only thing that needs to be changed is the class name. Don't try to over-abstract. Don't try to put everything that is abstract logic somewhere else. It's fine to duplicate code, because you will have to change these commands at some point. The events, not so much, but user check it out. Checked. I don't know irregular verbs in English. So we have now an event. We have a command. I'm going to implement this part of the logic, this time from the aggregate first. So in the aggregate, I'm going to implement the checkout functionality. The checkout functionality looks the same. User checked out. I'm going to implement this when user checked out. Same here. We're going to ignore it. I'm going to implement the command handler on the backend layer. This is your actual API now. The front-end API, the HTTP, is not really your API surface now. The surface of your API is the commands that you allow the front ends to send. So one can be the iPhone app, one could be the Android app, the other one could be the HTTP backend, and something like SAP may be talking to your system if you are unlucky enough. So, check in user, check out user, same stuff except check out user. That's the command handling part. And now the front end, we need to change the index PHP, and we're going to just copy paste this stuff. Copy paste driven development, that's right. If they ask me, you didn't hear it from me. Check out user. This is a checkout user, yes. Now if I did everything correctly, it should run. There is like a 50% ratio of success here. Marco, it's loading, okay. Let's see if it's in the event stream. Yes, it's there. So this is a checked out. One thing that you notice here is that I can do it as many times as I want. Blah, it doesn't matter because there's no business rule behind it. Nobody said that you cannot do it. There is no rule behind it. So that's what we're going to do next. And so I'm going to stop this. And what I want you to do, and I'll give you this branch now, the feature checkout, is you need to modify this logic so that it crashes when you have a double check-in or a double checkout that is not allowed. Okay? So think about it carefully. It has to be written only in the aggregate. You don't need to modify anything besides the aggregate for this particular exercise. You need to make sure that you cannot check in twice or check out twice in sequence. So let me give time to commit here. All right, and I'm going to push it up. Right. I need to fix this. So, check out this branch is feature/checkout. So do a git fetch, check out the branch. Should be in line, should be working. You need to throw an exception when a double check-in or a double checkout happens. When it happens, not when it happened. Careful. And again, this is only in the aggregate. Down here. Yes.
I can check out if I didn't check in.
Correct. Yes. Oh, you cannot check out if you didn't check in, of course. It doesn't make any sense. You're not in the building, so why are you walking out? Somebody let you in from somewhere else. Just a tip, this is where these when methods that we left empty, this is where they click in. You don't need a read database here, no, because the aggregate is the building, it knows who is inside. It can know who is inside. Plus, you can consider that It's a building. How many people can there be in there? Do you really need an external database to keep the current users in the building? Could be 1,000 people. Still tiny stuff for in-memory stuff.
There could have been millions of people coming.
This is not the Tube of London, okay? You don't design the metro stations of London like this. London, yes. Okay. So the read model is coming, by the way. We are doing this in a bit. Let me give you a hint here how it works. So the idea is that you want to check if this checked in users, something like this. If array key exists with the username and the checked in users, then you throw new domain exception because we're in the domain. No, don't use this, but whatever. And we say user is already checked in username. So this variable obviously doesn't exist, this property. The opposite on the checkout. If not array exists, then it is not checked in. It's the same thing. All we need to do is we need to create this list of currently checked in users. So I'm going to create a private property. And this is going to be an array of actually a null list. I like doing null lists. This is also another weirdness you can see in my code sometimes. Indexed by username. And then we populate and remove items from this list where? In these when methods. Why do we do this? Because these when methods will also be called when you unserialize from the database. So you're loading from the database 100 events about this particular building. It's going to find all the when methods and call them all. So when this event, when that event, when this event, when that event, is going to call them in sequence. So it's actually replaying state. So when the check-in happens, then you have a checked-in users with the event. And here I need to provide an accessor, which I didn't. So public function username, returning a string. Yeah. This payload username. And the user checked out as well. Also needs that. Actually, I lied. I'm sorry about that. I should have added these methods myself so you didn't have to edit anything outside the aggregate. Forgot about it, sorry. So event username. And on the other side, we're doing the same here. We're going to say unset this time because it's checking out. Will this blend? That is the question. Let's run it. So I'm going to try to check in. Marco. All right, Marco is already checked in. Let's go back. Can I check out? Yes, Marco. Can I check out again? No, I'm not checked in, so I cannot do that. So this is relatively simple to build. We really added very few lines of code. Of course, you have to consider that this is a very affecting memory very much. But we are building a state machine in a much simpler way, because now the state machines that we drew this morning, where you go from state A to state B, every transition is an event, something that happened in history. Whether you can make that event happen is the decision you need to take. But that's what happened. You get the aggregate. It's an empty aggregate. What this repository is going to do is it's going to move all the states, all the transitions until you get to the last state. After that, you can call a method on the aggregate, and it will eventually produce new state transitions. So it's really up to you to decide. So let me commit that. Prevent double check in. Now, I'm going to take control here because it's gonna be a bit hasty otherwise. And honestly, I would prefer to have a few minutes at the end where we discuss stuff, especially what you didn't like about this, because it helps me improve this either way. So the idea is that we have the check-in and check-out, and now it crashes. Now, the point of having such a system where events are fired is that we want to react to these events. So when a thing like this happens, so we have a double check-in or a double check-out, what we want is we don't want to have a crash. We don't want to have alarms and sirens and stuff. What we want is to start a Twilio call to security and tell them that the person with this badge got into the building and they probably used the badge twice. Has anybody been at the Facebook HQ just for fun? It's kind of creepy. They get the badge and they know exactly in which room you are because you have to tap it at the doors. So, yeah.
Can you push to the remote?
Yes, absolutely. Yeah. So now what I'm going to do is I'm going to show you how to react to events. So what we're going to do is we are going to register one of these policies up here. So what I want to do is that when there is a double check-in or a double check-out anomaly, I'm going to call it like that, I am going to notify security about it. So the first thing to do is I need to first raise an event. And this is where we discussed also this morning. Sorry if I'm using Marcelo's workshop as a base for this, but the idea is that you have an external system, which is the security system, let's say, and you have to tell them when something in your system happens. So this policy thing is a very, very good way to have a separation of boundaries between your domain and somebody else's. So anything that happens and you need to communicate it to somebody else, you use one of these policies. So I'm going to, first of all, modify the aggregate and create a new event. So I'm going to call this check-in in anomaly detected. And I'm not going to change anything because I really only want the username that caused this anomaly. So actually username. And yeah, I'm going to use it like this. So this event will be fired instead of an exception when there is a double check-in. So let's go back to the building. Here, if this happens, then I have an anomaly. So there is one tricky thing. The anomaly should probably be recorded after the check-in or the check-out, not before the check-in or check-out event. All right? So it's very simple, but I'm going to say anomaly is equal that. So this is a Boolean expression. And I'm just going to move this Boolean expression down here so I can record the event after. If anomaly, then I'm going to say, I'm going to record that anomaly detected with this information. That's how you write it here. I'm going to write the same down here. Yeah. So anomaly is the opposite here. So it's relatively simple. So we swapped out an exception for a new event, which is what we were discussing earlier. How do you let the user know that they did something wrong? Well, you send security after them. There is an advertisement by, I think, a center about it right now. It's really, really creepy. Guy going through the metal detector and falling down a trapdoor. It's kind of terrible. So, okay, we are firing these events. Let's try this real quick. Does it work? I'm going to check in multiple times. No. Ah, yes, I forgot this when check-in anomaly detected. Yes. Down here. As I discussed before, the reason why you have to have these when methods, even if they're empty, is that you may forget that you have some events that you're never handling. So you need to have it empty just so you don't forget that this aggregate can also have events of another type and you're not accounting for them. This is a void method. Doesn't do anything. All right, let's try it again. Okay, Marco. Okay, let's go and look at the database. There we go. We start having a few events. So you see we start having anomalies. One other thing that you can see is that previously we added an exception, but nothing before we introduced exceptions prevented this. So our logic should unserialize data from the past where it was perfectly legal to do this. You should never throw exceptions while loading history. It's like jailing somebody because they committed a crime that was not illegal before the law was introduced. That's pretty much the idea behind it. That's exactly what we're doing here as well. So as you can see, checked in, checking anomaly, checked in, checking anomaly, checked in, checking anomaly. Now, what I want to do, and this is something that I wired together, so it may be kind of a tricky or complicated approach, is in the container PHP, I made some bindings in order to allow the event store to push around events. So this event bus thingy pushes events to various listeners. And I have written a convention where I basically take the event class name and then I use a suffix. This is very similar to what you have in Symfony with tagged services, except it's a more rudimental way to do it. So I have just the message name, just listeners, and that's the service name. So I have to write a listener down here, which is going to be check in anomaly detected dash listeners is a function, receives the container interface in order to be able to produce a list of callables, because you can have multiple event handlers for every event. That's the difference between a command and event there. Command only one endpoint, event multiple listeners. A command can be stopped, an event cannot be stopped. Okay, so if you have something like stop propagation, that's probably not a domain event. So we're going to return an array. And in this, we're going to say function. So as you can see, this takes more time. I wouldn't expect you to type it. It's just like a lot of conventions that I do in the 8 hours version of this workshop. So anomaly detected. I'm going to say here, I'm going to, for now, do an error log anomaly detected with the username. That's sufficient for now. So this is just to see if it works. I'm going to do it again. And there we go. Anomaly detected. You have it in the output. Do not put input-output operations in these handlers. Why? Because these handlers are executed in memory immediately, which means that if you have 100 of them and you have an event going out, you're going to be blocking everything until all these handlers are done. And plus, if any of these handlers fails, you cannot really replay them. So there are other architectures that handle this, not this particular one. There is another approach to this, which requires a bit more experience with the pattern itself, which is the one that Matthias Veras suggested. So now what you need to do here is that you are now communicating intent that you want to send security after this person to another domain. How to do that? You create a command. So I'm going to say, I'm going to create a command down here, which is called notify security of breach. I don't know, let's call it like this. Notify security of breach, it receives the same parameters, it's the same stuff as before. All I need to do is in the container down here, I have to say I'm going to receive the command bus. So I'm going to copy Yeah, actually down here. Container get command bus is the command bus. And I'm going to use it in the closure. This is our actual policy disclosure. So this is something you should probably put in the domain later. You make it a class, you test it, you put it in the domain. And here we say command bus dispatch with notify security of breach from building and username. So this receives the anomaly detected aggregate ID, which is a string here. So I need to do some conversion. If you use proper types, you never really need these conversions. From the outside, you never return a string. Don't return strings in general. Produce a stringly typed piece of code. And the anomaly detected with the username. So this will fire a command, and this, since everything is happening synchronously, since we don't have a command handler for this, it will crash. Let's put it down here. And now on this side, you can do it. So you do a notify security of breach on this side. And now here you put the error log. Security breach in blah by blah. All right, and that's command building ID to string and command username. There we go. Let's run it again. Marco is doing it again. There we go. Security breach in etc. by Marco. Why? Because command handling happens here, which means that you can retry the interaction if the email service is offline, if Twilio is offline. Anybody using Mailgun or MailChimp, right? It goes down once a week. You can't do much about it. So you need to be able to retry, especially for this stuff. This is important. This is security. So this can be retried. This cannot. Not in this setup. You can fiddle it around until you find a setup that works in such a way that you have transactions on the other side. It's up to you to decide that. This approach requires that anything that causes input-output goes through the command bus. The reason is because the command bus gives you the abstraction for logging, extremely important. As soon as you have asynchronous processing, if you don't have logging, you're doomed. You have no idea what is going on. Retrying, and eventually scaling. If you need to scale this to workers. If you need to send this information to 100 police stations, you're not going to do it sequentially, one by one. Start the call, wait for the call to be picked up, and complete. Not how you want to do it. So that's how you convert from the exception to a new event type and catch the event type, use it to funnel it through a policy and make it contact a separate domain, which maybe is another aggregate or maybe it's a different system, such as a payment gateway. Up to you. Just make sure you don't put credit card information in events, because events are forever. So in general, you shouldn't save them, and then absolutely not forever. Forget that I said that. You don't save credit cards, period, okay? This is a new feature. And this is the anomaly detection. Yeah, of course. So, the other thing that we need to cover is projections. So, we now did this part of the diagram. I'm going to push it in a second. We did this loop. So you can now repeat the loop as much as you want. If you put it on AWS Lambda and you have an infinite loop, you get an infinite bill. It's going to be really expensive. We are going to go down this way now. We're going to make the projections. Yes, yes. I need to restart GPG agent every time I unplug this YubiKey. And if I commit, I can push. If I push, I can't commit. Yeah, technology. Okay, so next thing, we need a list of who is currently in the building. Why? Because we want to make a shiny dashboard, and this dashboard is going to refresh every second. Okay, very, very stupid. We're going to refresh this page every second. And this page, I don't know, we have a UI that uses it, so it needs to be highly available because we maybe have 20, 30, 40 dashboards, and maybe the entire machine that actually hosts the actual list is an Arduino. Probably not an Arduino because the Arduino can't run PHP, but a Raspberry, so you don't want to choke it. But anyway, we are going to simplify the interaction by reducing the list of current users in the building to a file. You don't need a database, you don't need to invent the REST bundle something in order to have a working cacheable list of things. You just put a JSON file in a .json file in the public directory, and that's okay. It works, it's fantastic. Files. Less frameworks, more files. So, how are we going to do that? So, the first thing is, I don't really want to trigger this manually with a cron job or something. So, what I'm going to do is I'm going to use another key that I invented myself here. So, this entire container PHP is invented by me. There's nothing like special coming from the framework. This entire file, you can read it top down and you can rewrite it yourself. It's obviously a lot of the interdependencies, but it's still not even 300 lines of code, and it has all of that. So we are going to say user checked in. When user checked in, we are going to reproduce, we are going to run a projector. So that's how it works. Now, except that a projection doesn't really run a command. All it does is it will run a query and copy data from A to B. So I'm going to say this is the event stream. So this is the history that we have in the entire application. Event store. We are not streaming, we are querying, which is different. Streaming is for the observers, which is for functional reactive patterns, which is for another person to explain, sorry. So, what happens is that every time a user checked in event is triggered, this function will be called. Every time this function is called, we want to copy the history into a file that says these are the users that are currently here. So, let me see if I can remember this. This is event store, load events by metadata from, and I'm going to say new stream name, and the stream is event stream. Why event stream? Event stream comes from the name of the table here, because you can have multiple streams and separate them if you want. It's up to you to decide that. And I'm going to filter by aggregate ID, and the aggregate ID is the anomaly detected aggregate ID. Sorry, this is not anomaly detected. This is I'm going to call it check-in interaction, because the same logic has to be executed both for check-in and check-out. So I'm just doing it for check-in for simplicity for now. These are the events. So for each event, events, why? It's just events, that's why. All right. As event. So if the event is an instance of the user checked in, then I'm going to push to an array. If it is an instance of user checked out, I'm going to remove a key from it. You saw this before. This was in the aggregate. It's the same exact logic. Why am I duplicating it here? Because if you rely from the front end that is doing query operations on the aggregate, you are coupling the write logic of your application to the read logic in the front end, which means that you will no longer be able to change the logic of the aggregate if the business rules change. So please don't read data from the aggregates. Use the aggregates only as a mean to decide what you can or cannot do and what the next state is. So let's see. I'm going to say users is this one, is an empty array. I'm going to push users of event username is equal null. And here I'm going to unset. And down here I'm going to brutally say file put contents with the current directory, which is, where are we? Yeah, public / building, and I'm going to say the event aggregate ID. Sorry, not event. I'm going to take this check-in interaction, aggregate ID, .json. And inside, I'm going to serialize as JSON just the list that I produced. I really need to get better at typing. JSON encode of array keys users. Will this blend? I have no idea. Let's try this. Okay. Marco checked in. Let's see, is it there? Ta-da! Okay, that's it. So Marco, Joe, Fritz, Franz, and Otto. I live too long in Germany. There we go. Okay, that's all there is. Of course, you need to decide whether you want to run this immediately when an event is triggered, whether you want to run it on a separate machine that is constantly doing it and publishing events. But isn't this better than setting up Phosphorus bundle? It's a bit easier, I think. This is cached. You put a varnish in front of it. It doesn't care. It works great for porn websites. Apparently. Yes, I'm not being very educational here. Okay, so I would have to do the same for the checkout. Let me do the same here. Franz, Fritz, and Otto. I'm going to check in as foo here, just to make sure the view updated. It's a bit of a hack. There we go, they're gone. So this is extremely inefficient because what I'm doing right now is I'm querying the entire stream for that aggregate. We talked about it. This is a fold operation. And everything that happened in the past is history that we can rely upon. So what we can do is later, if you want to optimize this, down here, you can specify the first version you want to loop. So if you were to put the latest version you looped upon in here, you can only get the last events. You don't need to loop over all the history. You can get the current JSON as initial state and then work with that plus the new events. So you can make it extremely efficient. And that's how you write projections. And it is not nice. It is a lot of work. On the other side, if you use a database for the storage of the event stream, you can throw this work at the DBA. They love this stuff. They like writing queries. They're good at writing queries. They will write something that you can't understand, but it runs so fast because it doesn't need to go through PHP. And it's their work to synchronize them. You can use a materialized view. You can invent whatever contraption you want, and it just works. So that's amazing, in my opinion. That's really, really simple. So this is what a projection looks like. Let me see. What else was there? Yes, I got half an hour. So what I'm going to try to show you how this can be eventually integrated with a testing tool, BHAT. No, I'm just not going to call it testing tool. This is A new branch. What did we do here? This is the user's projection. It's a testing tool, yes. You can tell him when you're back there. And it's a fantastic UI testing tool. Okay, yeah, there's a running gag. BHAT is a behavioral-driven development research tool, I would say, in which you write sentences and software emerges from it. But most of the software that I see tested with BHAT has, when I click on this button and I click on this button, then I should see this. And every second company that uses BHAT. She's sad, but it's the actual truth. So, okay, so let's see. Risky, do I have BHAT? No, I don't have it. BHAT. That could be really risky because I'm writing it on top of my head right now. So the idea is that now we have an event store that stores the past information, history. We have interactions, something that happens now, and that produces new history. This has the interesting effect that on the language of the domain, it simplifies things a lot. Because now who has used BHAT here? Who has not used BHAT here? Okay, so we'll see that in a second while it's downloading the world. BHAT gives you this language which is called Gherkin. It's an actual more formal specification in which you can describe what the system does in plain English, in layman terms. That's what plain English is. It's a very, very simplified version of English. So you can write scenarios that will be run by an automation tool. They read as English, so they're understandable to the normal mortal that has no idea how we are doing this stuff with computers. And it still is actually testing the behavior of our application. So, BHAT-based aggregate testing. Let's see, this is going to be a bit speedy. So what I need to do is, first of all, I need a specification, feature, and I'm going to say check-in feature. So this is the feature, and I'm going to say this is check in and check out. We have a scenario, check in, given a building was registered to the past. When I check in when a user checks into the building, then a user should have checked into the building. It reads a bit like haiku, okay? It is a bit clunky. But this is like brutally simple. It's like legal terms. When you go to a legal process, they really write down every word and the meaning of every word like in such a way that it's impossible to misunderstand stuff. Let's write one that is not so trivial. This is double check in raises anomalies. Building was registered, and a user has checked. Just checked into the building. When the user checks into the building, then the user should have checked into the building, and this is D. Sorry. Wording is kind of important. And an anomaly, a check in anomaly, should have been detected. So this is not so trivial. This is a bit better. And you can keep doing exploration this way. It's it's clunky here. It's very clunky because I don't have a business language. This is something I am inventing. But you can really like write pages and pages of this, and you find conflicting scenarios. And what we discussed today, for those that were in the other workshop, when we had so many questions about what can you do when you go from A to B, you write a new one of these scenarios for every time you have a question like these, and there is an ambiguity. You write a new one that describes where you want to go. So I'm going to copy from another workshop because shit is soft. Okay. PHP Framework Days, please tell me they have a Behat. Yes, Behat YAML. I don't know YAML. Why do you still use YAML for Behat? Yeah, ask Konstantin, please. Okay, so we have a specification check-in, check-out, a feature check-in, check-out feature. I'm going to actually rename this to match the naming. And I'm going to write a class. So I'm going to make a test namespace. So this specification is something that comes from business. These sentences is something you discuss with business, because I don't expect the business people to write this sort of plain English anyway. You have to teach them, and it's going to take 3-4 years before they grok it anyway. It's going to take 3-4 years for the developers to understand what the business is saying anyway. You know, it goes both ways. So this is a test specification, and in here, check-in, check-out PHP. Check-in, check-out is a what we call a feature context, which is basically like a PHP unit test. In PHP unit, you run a test, and it will just execute a set of methods and look like at methods that start with test. In Behat, it happens the other way around. Behat will go to the feature files and look for a file that has methods that match that file. Check-in, check-out implements context. Yes, and here in the namespace, specification. No, just specification, please. All right. Okay, so public. Okay, let's split it. Otherwise, we have no idea what we're doing here. I need this and I need this. So public function, a building was registered. Void function. So what you do is you mark them with annotations. So you see it went from yellow to white here, so you can now bind it together. So you have an idea of where the heck your tests are. So what I can do is I can have a set of past events. Which is empty. This is a aggregate changed list. And on this side, I'm going to say this past events, and I'm going to push a building registered. Occur, I'm going to create a new aggregate ID. This is to string, and a payload, which is the name of the building, which is, well, should be randomized for a better test, but the building name. This is the basics of how it works. And you keep going through this, and at some point you have a when, and this when interaction has to use the current aggregate object and call something on it. So I'm going to copy this. And this is the user checks into the building. And here, this is not an event. This is to the present. So now we have to do the actual business interaction with the object. So this is where the actual testing happens. The previous one is precondition, and the then are the post conditions. You are verifying what is happening later. So I'm going to say we have a private function aggregate, which is returning a building. To do. I'm going to say this aggregate check in user with Fritz. I like Fritz as a name, apparently. Okay. Right. And then we have to check the post condition. So this is when, and this is then. Then the user should have been have checked it into the building. This is a bit weird. Should probably be should have been. So what we want to do now is we want to say something like this pop last event. Right? And we're going to say if not event is an instance of user checked in, then we throw new exception. Nope, this is invalid. That's kind of the idea. I'm going to implement this. And here we do some hackery. This is kind of ugly stuff. Function pop last event is going to give me an aggregate changed object. You are free to use your own implementation of events. This aggregate change comes from Prooph, which means that it's a framework, which means this framework leaks into your domain. That is a problem for those that are practicing domain-driven development. But honestly, this stuff is hard, and this library makes it so much easier. So it is technical debt that you are accumulating just by having that framework in there. It's just worth having at the very beginning, especially when you don't know what you're doing. Use the framework because these guys made it correct. I'm going to say this aggregate is the aggregate. And now the aggregate, interestingly, this building has a protected method, which is pop recorded events. Ta-da! So pop recorded events is something we can call, and it will fetch everything that the aggregate has loaded so far, and it will give it to us. So I'm going to use reflection, because I'm a horrible person. Reflection method with the aggregate and pop recorded events. Let me close this, not really needed here. It's better. So reflection pop, we make it set accessible true. Why would anybody use reflection and not have them accessible anyway? I don't understand this particular method call. Did it for years, it makes no sense. And then reflection popped invoke with the aggregate. This will give us the events. And we need to cache them locally. Private recorded events. This is going to be an aggregate changed or null. So I'm going to do it this way. Return this recorded events, or this recorded events is equal the pop. So basically, if I already popped, I'm going to ignore it and just use whatever I recorded there. This is going to get the last event. And I want to get the array shift, is it? Is it array shift the one that gets you the first one on the left? There we go. So this gives me the last event. Now comes a much uglier part. This cannot be done with the reflection, and it's done by the framework again. If you looked at this aggregate root, it has a reconstitute from history, which is a protected static function reconstitute from history. There is no way to call this function from reflection. It's by design, because it's a static method. And Prooph uses some hackery in order to prevent your public API on the aggregate to contain API that is technical. Your aggregate should only contain domain interaction, no technical bullshit. So I'm going to call this, and it's going to be a bit ugly. So I'm going to say closure bind with a function that receives a building. No, it receives nothing actually. Receives events. Yeah, that's what it receives. And I'm going to bind it to building class. And I'm going to invoke it with this past events. And here I'm going to say return building reconstitute from history with a new array iterator around the events. So this is going to stay red in your IDE. There's no way to fix this because we are actually breaking the rules of the language. The framework does it for you as well in order to prevent you from having framework API in your domain, public API in your domain. Return the building. I need to actually also say if the aggregate is already there, please don't rebuild it. So return this build aggregate. Is it called like? Yes. Aggregate is equal that. Let's see. I have no idea if this will work. It's all on top of my head. Last thing, composer autoload definition. Otherwise, composer doesn't know how to load our tests. This is going to be specification. It's a test specification. All right. Vendor bin bhat, everything broken. Everything broken. Closure bind expects parameter 2 to be object string given. Closure bind 2. Is it closure bind or closure bind 2? Ah, yes. No, comma, building. Let's try it again. There we go. We have an actually executed test. So it was a bit of a jumpy road, and it shows how hacky this framework is deep below. What we are doing is we are recording some events. So given, and so on. You add events of what happened in the past. When thing happens now, then something happened in the past. Verify. So if you write this sort of language in the tests and you keep adding and adding more to this, it is extremely trivial to test that your aggregates work without having to resort to doing a Selenium test. This doesn't need a Selenium test. You write this is like a pseudo unit test. Except that in theory you should start from here and write the aggregate starting from here. So you have events and so on and so forth. So I think that concludes the practical stuff. I would ask if there are any questions.
There's a trick to get the first element of the array without changing the array.
There is. I probably don't want to know it.
Reset.
Reset, yes. No, but I want to pop, because the next test is a different test. The next test would do the other thing. It would pop twice. That's why I did the array pop. Sorry, I didn't finish it. But yeah, this is the other stuff. So if you go to github.com/shittysoft, I need to make a company out of this. So if you go to shittysoft, I did this, for example, for Trivago recently. And what I did is I provided a set of pull requests there. And it's about this workshop. So let me zoom in. So as you can see, it's the same domain. Start from the bottom, check in, we did that. Then we did the checkout. Then we did the prevent double check-in and checkout, which is the same functionality, just with the exceptions. Then we did the detection of check-in anomalies with handling, as in there is an actual process manager or policy on the other side waiting for these events and processing them. Then there is specification testing with BHAT, like this one. So you can actually, I mean, this stuff is very technical, but you see that it reduces the distance between domain language and the code. Because now you have events, aggregates, and commands. So imperative verbs, subject, which is the aggregate, and event, which is a fact, happened in the past. We had the projector, we wrote that. So what is missing here? I don't even remember how far I got last time. Right, so if you look at the repository and you want to go crazy with it, you can look at the other pull requests here. But you can switch to asynchronous processing of all these commands, such as the command goes to the front end and it will be processed by a worker on the back end, with like 5-6 lines of code changes. And then the last thing, which is a bit tricky but is still interesting, is how do you check? How does the aggregate check whether a user is allowed to check in or whether this user is in a blacklist or not? So this is interesting because what you use is then you have a read model or some API down here that says who can check in and who can check out. It's down here. And in the business logic, in the aggregate, you can read that. That's where the service layer kind of reappears, kind of. Because what we do is we have this thing called a read model, which is an abstraction on top of a read layer. So let me show it. Yes. So you have like a user blacklisted interface. You have real Donald Trump and mom. They're not allowed to check into the building. You don't let those in. And then in the aggregate, all you do is you pass it as a parameter at call time. So it's not really injected as a service. You do it in the command handler. The command handler has access to all these services and so on. You just pass it as a parameter to the check-in interaction. Extremely easy to test, extremely easy to write BHAT scenarios around this. You say, I got 2 blacklisted users and I check in, then I should not be allowed to check in. Just examples. But you see, it kind of closes the gap. Where did the services go? How do I do this other validation stuff? With that, I would conclude here, I think. So if you have any questions, and especially for those that didn't get to see the diagrams, please come and talk to me. I wish that you at least got to follow those along. We can do that on paper. We can discuss it later. If they don't let us the room, stay in the room. But please come talk to me. Thank you very much.